What happens when a math teacher and an art teacher work together to design a project? These images show some possible results of this type of collaboration. Beautiful works of art that incorporate interesting mathematics. This project also gives us a lens that can bring a new clarity to mathematics standards, inspiring new possibilities for student work. The Common Core State Standards include two types of mathematics standards: content standards and the standards for mathematical practice. The standards for mathematical practice provide broad statements about how students can think like mathematicians, by reasoning abstractly and quantitatively, by attending to precision, and so on. These standards encourage students and teachers to explore the abstract beauty of mathematics in addition to its usefulness and applicability. Students can use these skills daily in math class, but they can also engage with these standards through longer-term projects. Students at High Tech High in San Diego created artwork that included representations of mathematical concepts. Their creations were displayed in the school and archived in a published book called Calculicious. These seniors each created 3 works of art over the course of a semester of work in both their math and art classes: a watercolor and an acrylic painting, and a sculpture which they worked on with 1 or 2 other students. They created preliminary sketches and drafts of their works, investigated the mathematical properties and concepts involved, and posted their final products with commentary on a class website. 3 students, Brad, Carl, and Sam, created a sculpture by stacking painted blocks and investigating the centers of mass of their structures and how far they could hang over the edge of the table without toppling. They displayed their piece with a poster behind it, including descriptions of the math they used to create their structures. Their words and the equations that accompany their explanations show some of the math they explored in creating this piece. One of their structures involves stacking blocks in multiple directions, which they showed allowed them to overhang the table to a greater extent than the same number of blocks stacked in one direction. Their unidirectional stack of blocks, they found, follows the harmonic series. The top block overhangs the second by 1/2 a unit, the second overhangs the third by 1/3 of a unit, and successive overhangs are 1/4, 1/5, and so on. As a result, the total overhang of the structure is equal to the sum of the harmonic series shown here, which, as they explain, diverges to infinity and has no upper bound. Before we take a closer look at their explanations, let's revisit a couple of standards for mathematical practice. Standard number 7 says students should look for and make use of structure, that they should be able to look closely to discern a pattern or structure, and step back for an overview and shift perspective. Students who are using this ability should be able to look past numbers and calculations to make connections to more abstract concepts and ideas. Standard number 8 asks students to look for and express regularity in repeated reasoning. They should maintain oversight of the process while attending to the details, and be able to find patterns in their calculations and use these patterns to simplify their work or connect to a broader concept. The sculpture Brad, Carl, and Sam made and their explanation of the math involved required them to use these 2 standards for mathematical practice. They described the interesting relationship between the harmonic series and total overhang they found in their stack, and explained that this means the maximum overhang for a single wide stack is unbounded. They apply this relationship to see that for a 100-unit overhang, the minimum number of blocks required is greater than the number of particles in the known universe. They included these statements in their description of their sculpture, which is shown in the Calculicious book opposite the image of their structures. These statements show a use of patterns and structure and a willingness to look beyond simple calculations to find and use a deeper concept. These students were not merely doing math. They used this project as an opportunity to study and discover beautiful patterns in mathematics, and to explain those deep patterns to others. As we, as a nation, transition to using the Common Core State Standards in our daily learning and teaching, we should ask, how can we invite students to explore and enjoy the deep concepts and patterns in mathematics suggested by the Standards for Mathematical Practice? This type of teaching is not easy. It requires teachers themselves to have a deep understanding of math and to be comfortable taking risks with their students. If we can lean into this challenge, however, the results can be extraordinary: beautiful, elegant, and deep celebrations of mathematics.